Hello, ladies and gents. Okay, so the next differentiation topic that we're going to have a look at is the quotient rule. Now, the quotient rule is for when we have a function divided by another function. So, for instance, if we've got y equals x cubed over sin x, then we've got a function on the top, we've got a function on the bottom, and so we can't differentiate it using the normal method, so we've got to differentiate using the quotient rule. Now, the quotient rule is if we've got y equals u over v, then when we differentiate that, dy by dx goes to v du by dx minus u dv by dx all over v squared. Now, this is in the formula booklet, but I don't think it's in a very easy to use form. And so you're going to be doing loads and loads of these questions, especially when it comes to doing revision. And even though you should write down in the exam v du by dx minus u dv by dx, when we talk about it in class, we'll refer to it as v du minus u dv all over v squared. And as long as you know that du means du by dx and dv means dv by dx, that's probably the easiest and snappiest way to remember it. So v du minus u dv. Okay, so how do we use this? So we've got a question here which is y equals x over 2x plus 5. So again, what we've got is we've got a function divided by another function. So we've got the x on top and we've got the 2x plus 5 underneath. So the first thing we do is we decide what u is and what v is. So we've got u equaling x, and we've got v equaling 2x plus 5. So once we've got u and v written down, the next step is to do du, or du by dx if we're being thorough. So if we if we differentiate x, we get 1. If we differentiate v, we get 2. It won't always be this simple, but obviously to solve it's better to have a simpler example. So we now got v du minus u dv. Remember it's that way around, it's v du minus u dv all over v squared. And just be careful when you write this out, because obviously it's easy to make your v's and u's look the same. So it's always worth putting a little tail on the u there. Okay, so v is this one, and du is this one. So if we substitute that into a formula, we're going to get 1 times 2x plus 5, which we can just write down as 2x plus 5, minus u dv. So that's x times 2, so that's minus 2x. That's all over v squared. So just in case you're not confident about doing this, 2x plus 5, and just write it squared. And then sometimes you'll be able to simplify or expand out the brackets to x plus 5, but most of the time you don't need to. Okay, and then it's just a matter of tidying it up. So once we've done that, dy by dx equals 2x minus 2x, that just goes. So you're left with 5 on top. So we've got 5 over 2x plus 5 squared. And that's pretty much the nuts and bolts of how we do the quotient rule. And there are going to be other examples. We'll go through one more example before the end of the video. But a lot of the quotient rule will turn up in the exams, but you won't be able to do the differentiation until you've done the rest of the videos, because there'll be functions like log x on top. So we could have log x over x cubed, and at the moment we don't know how to differentiate log x. Or if we've got x to the power of 4 over e to the power of x, we don't know how to differentiate e to the power of x at the moment. So we'll see more of those a little bit later on. But for now, let's see if we can prove it. So by expressing y equals u over v as y equals uv to the minus 1, prove the quotient rule. So what we've got here, the way it's written like this, it looks like the quotient rule. The way it's written like this, it looks like it's the product rule. So what we're going to do is we're going to use the product rule on this second function here. So we're going to say that u equals u. And we're going to say that v equals v to the power of minus 1. So du by dx just equals du by dx. And dv by dx, what we're going to use is minus v to the minus 2 dv by dx, just to show that we're differentiating with respect to v. And then what we're going to do is we're going to pop all our four results here into the product rule. So the product rule, if you remember, is u dv plus v du, and of course never forgetting that it's actually dv by dx and du by dx. Okay, so u dv, that's going to be u times dv. So if we do that, we get u times v to the power of minus 2, of course there's a minus in there as well, dv by dx, plus v du, which is v to the minus 1 du. Now at the moment it doesn't look much like our rule, so we're going to simplify this down a little bit and tidy it up. So because we've got here v to the power of minus 2, we're going to put that on the bottom. So it's going to be minus u dv by dx over v squared. If we do the same with the second function, we're going to write that as du by dx over v. Now, as we often talk about in class when we're adding fractions when it comes to C3, C4, or indeed C1, C2 as well, we can't add fractions if if the denominator isn't the same. So in order to make the denominators the same, we've got v squared here, and we've only got v here. So we're going to need to multiply this one, the one on the right, top and bottom by v. So if we do that, we get minus u dv by dx over v squared plus times the top by v, which is v du by dx over v squared. If we add those two together, we get dy by dx equal, and if we swap them the other way around, we get v du by dx minus u dv by dx all over v squared. So that would be how to, and that is the quotient rule that you don't necessarily need to memorize because it is in your formula booklets, in the pink formula booklets you get in your exam, but this way is far easier to remember than the other way. Okay, what I'd like to do now, please, is have a go at exercise 8C and have a go at all of those questions. You've got questions 1A to E, and you've got question 2 and question 3.